So, wow, bright lights. Hi everyone. We're going to be playing a game that I hope you will find both fun and educational. I'm going to be asking you a series of JavaScript riddles that I expect you to try to answer. And anybody who does manage to answer one of these riddles will get this excellent prize. I'm going to hurl a rubber duck at them. Unfortunately, not much of a prize, but at least it won't hurt anybody that actually gets hit. And also do me a favor. If I'm probably going to miss, especially with all these lights shining on me, so do pass them on to the correct person. We will pass microphones around, so don't just shout out the answer, just raise your hand, and hopefully the correct person will get the microphone and then can try to provide the answer. So Proust was really kind enough to give me this great introduction, so I will just say that indeed I've been with Wix for the past 5 years, focusing about performance, but again, this is not what we're going to be talking about. We're going to be talking about JavaScript, the language, and specifically riddles as a way to enhance your knowledge of JavaScript. So, this is a JavaScript conference, and, we do web development, and when we consider the role that JavaScript plays, JavaScript is probably our main tool in our toolbox. This is what we do most of the time. And it's a surprisingly sophisticated tool. I mean, think about the fact that JavaScript was originally created because Java was considered to be too complex and sophisticated for most of the people who will be creating stuff for the web. So Java was intended for the real developers, and JavaScript for the various hobbyists that will just create some content and will want to have some animations and move stuff around. But look at us today, and we're doing this really heavy lifting with JavaScript, and Java is kind of gone from the browser completely. And what's more, JavaScript just keeps getting more and more powerful and sophisticated. We're getting so many new features and capabilities all the time, with the arrow functions and classes and whatnot. So many features and functionality that are making their way into the language. And it got to the point where really knowing and understanding everything that there is to know about JavaScript is getting really, really challenging. And a way that I found to be really fun for me is by trying to come up with riddles and interesting questions about the language and then posting them on Twitter. And eventually this kind of evolved into this talk. So let's start. So here are the rules of the game. First of all, participation is a must. If you don't answer the riddles, I'm just going to be standing here and looking stupid, and we don't want to do that. So please do try to answer, and don't worry if you get it wrong. I mean, getting things wrong is the best way or the best route to actually finally getting things right. If you already know the answer to a riddle because you happen to have already seen the riddle, for example, in my Twitter role, then please don't participate in that particular riddle. Also, don't cheat. And by cheating, I mean don't use something like the browser console or Node or whatever to just, type the code and see what comes out in those riddles that involve code directly. And finally, as I said before, don't just shout out the answer, raise your hand. I can't see a thing, but hopefully the people here will, and they will hand you a microphone or at the very least ask you to shout it out. So let's start. So our very first riddle is going to be just a list of terms. What I'm going to ask you is, who can tell me the meaning of these seemingly English words, what they mean in the context of the JavaScript language? So let's start by seeing if anybody knows the answer. What do all three words mean? By the way, speakers can participate. You want to participate? Anybody here? We have a candidate.
I will try to. Okay, false is like empty string or false value or undefined or null, something like this. Tenable is something that looks like a promise. If you can do 10 out of it, and then nullish is like null or undefined, I believe.
Close enough. Good for you. Everybody, give a hand. See if I can hit you. Oh, almost. Okay, so to give the textbook's definition, so false is a value that's considered false when encountered in a Boolean context. So for example, when it's coerced into a Boolean value, or you apply a double not operator, like not on it, it will come out as a Boolean value. So as a false Boolean value, so it will be false, obviously, but it will also be undefined, null, zero, none, empty string, and I'm probably missing something. Thenable is literally just an object that has a then method. That's it, nothing more. Obviously, promises are objects that have a then method, but literally you can just create an empty object, assign a then method to it, and you've got a thenable. And what's really cool is that a lot of functionality in JavaScript that works with promises, actually all it looks for is the then method, which is, you know, the whole thing about JavaScript being reliant on duck typing, which is maybe why I'm throwing ducks. You know, if it walks like a duck and quacks like a duck, it's a duck. And finally, nullish is literally just either null or undefined. And it's apparently a term that's been defined in the context of these new operators, like the optional chaining operator and the nullish coalescing operator. The optional chaining is, you know, kind of, you can think about it as like a replacement for low-get maybe, that if the obj here is either null or undefined, instead of crashing, it will just return that and not try to access the property. And likewise, the nullish coalescing, kind of similar to having ampersand, but it's only applicable if val is either null or undefined. Okay then, moving on to the next one. This is really, so the math is, you know, math is interesting in JavaScript. It's actually a part of the IEEE standard, not really the JavaScript standard itself, but it's effectively part of JavaScript, and it has a lot of, you know, interesting and weird side effects. So let's start with this. Let's say I have something in X, which JavaScript considers to be a number, but can you give me an example of such an X, or actually 3 examples of such an X value, so that X minus X is different from 0. Bruce, you look like you're really roaring to shout out the answer.
I don't want to show everybody else.
Okay, any thought? Okay,
Here.
we have a hand over there.
I already have the mic here, so...
Oh, okay.
Okay, here. I'll try. So first of all, positive infinite, negative infinite, and not a number.
Correct. Everybody gives a hand. I don't know if I can throw this far. I can try. Okay, so that's an absolutely correct answer. So of course, obviously not a number, because not a number is our favorite number. And if you do any sort of numeric operation on not a number, what you end up is not a number and not 0. Likewise, infinity, because if you remember our math, if you subtract infinity from infinity, that doesn't really come out as 0, because not all infinities are identical, and obviously minus infinity as well. Okay then, so in a lot of job interviews, we get introduced to the sort of palindromes, like you need to code something around a palindrome or try to figure out a palindrome or whatever. But it turns out that in JavaScript, especially with the newer JavaScript syntax, you can actually write code that looks like a palindrome. And this is what I'm going to try to do here. So I wrote a bit of code, and that is a palindrome, but your goal is to say, first of all, whether this is actually legal JavaScript, or am I just throwing out a random sequence of characters? And if it is legal, what does it actually mean? So here's this bit of code. So assuming that X is a variable that has already been declared and is assignable, you know, either using var or let. Suppose I assign this thing, which as you can see, you can read it, it looks the same way, right to left, left to right. Is it legal? And if so, what is the value of x? Okay, so we have a raised hand over here. You guys are solving the riddles really quickly. I'll finish all the riddles and we'll still have time. You'll have an early lunch. Great for you.
Yes, it's valid, and it's an object that contains the property, well, it's square brackets, object, object, and the value is an array with an object.
So you're saying it's an object, okay, and it has a single property. What would be the key of that property?
Square brackets, object, space, object.
Okay, and what would be the value of that property?
It's an array with an object.
An array of one empty object. Exactly, absolutely correct. Oh. Okay, so a quick explanation. So this is indeed valid JavaScript ES6 code, which I found to be really cool. The fact that you can write something like that and it's totally valid in our favorite language. So let's see why it's actually valid. So with JavaScript ES6, one of the things that was introduced was the ability to have, in the object declaration, have property names that are computed. You know, in the past, if we wanted to have a property name that was computed, we would do something like create an empty object and then use the square brackets to assign a property into that existing object. Well, with ES6, you can actually have it as part of the object declaration. You just put as to the left side of the colon, you just put the square bracket with the expression that you want to compute inside those square brackets. So in this case, for example, I create an object that has a property called meaning of life. The key is meaning of life, and the value would be 42. In our case, we put in an empty object inside the square bracket, so it gets cast to string, which in this case becomes simply square brackets, object, object, close square brackets. And so we end up with this object. So what we wrote before is essentially exactly the same as what we have written here in the end. And on the right-hand side, it's just an array containing a single empty object. So far, so good. Okay, moving on to the next riddle. So I asked this riddle on Twitter, and I don't know if you know him, Carl Simpson, Getify, really a guy worth following and looking up his talks, an awesome speaker. He pointed out that even more interesting than the solution is the why. Why, so again, is this a valid value? What if it's a valid expression? And if it's valid, what is the value? And most importantly, as Getify stated, why is this value the value that we get? So, wow, you guys are really fast. I really like that. Awesome. Go for it.
As for validity, definitely yes. There are no syntactic issues. As for the value, the first part would, I would assume that's a false, the entire expression, because those are comparisons. It should reduce everything to a number.
So you're saying it's correct JavaScript syntax, and you're saying that the whole of the expression would be false.
I'm assuming so.
No.
Well, I tried.
Good for you. No, so now you know. Okay. Now, anybody else trying to go for it? Okay, we have a hand here. Well, the second time. Whoa.
Okay, so it's true, and undefined is converted to a number when it's compared to another number. It's not a number, or actually it might not be. But anyway, it's false. Undefined is not less than 1. And all is converted to a number and it's 0, so 0 is less than 1, so that's true. And then false is less than true because they're both converted to numbers. And false is converted to 0, and true is converted to 1, and 0 is less than 1.
Exactly correct. So you're a double winner. I'll give you a different color duck this time. Oh. Okay, so here's the explanation for in case somebody didn't follow along. So this is valid code because in JavaScript you can essentially do a comparison operator on essentially anything. And in the case of, so let's start with the expression on the left, where we wrote number less, we had undefined less than 1. So undefined, when you coerce undefined into a number, what you get in return is none. It's not a number. Undefined is not considered to be something that represents a valid number, so what you get in return is none. And none is not really smaller or bigger than any other number. So any comparison of none to a number will always come out as false. So this is why undefined is less. If you compare it to 1, the result is false. On the other hand, it turns out that when you coerce null into a number, you actually get 0. And when we compare, so as a result, when we compare null to 1, it's actually like comparing 0 to 1, and 0 is less than 1, so the result is true. And you know, JavaScript is kind of based in the end on C, and C, false and true are literally 0 and 1, so false is coerced into 0, true is coerced into 1, 0 is less than 1, so what we end up is a value of true. Okay then, moving on. This one is a bit challenging. Noam, I think you're the one that originally solved this the first time I showed this one in a talk, so you're excluded this time. Okay then. So here are two ways to essentially declare a function and assign it into a variable. So f comes out as a function, and the second one also f comes out as a function. The top one uses the old style function syntax, the lower one uses the new arrow syntax. My question is, given these two types of declarations of a function, how can we tell which one is used? So let's say you're given the f. How can you tell if f was assigned regular function or if f was assigned an arrow function? Okay, we have a hand here. You were first. Okay.
Yeah. So we can tell by looking in the window as the second one would have the this assigned to being the window.
Yeah, well, that's not exactly true, because if you're using useStrict, then in both cases it might be this value would be undefined or whatever gets called in. I'm not going to accept that because it's not sufficiently strict solution. It could be there could be problems with that. So we have, do we have another candidate? Here, over here.
Here. So still on this part, but we can try to bind the this while calling the function and see what it turns out.
Yeah, but that means you need to modify the action of the function and call the function. And I want to look more for a solution that without having to modify the function, which essentially replaces the function, if I can actually, like from the outside, figure out if the function is this or that. So
yeah, fair enough. I also had one more thought. But
okay, go for it.
I know that there is, I can't remember how to access it, but I know that when you declare a function like that, it gets assigned somewhere. If it doesn't have a name, it still gets assigned somewhere on the window, but I can't remember where.
No, that's not what I mean either. Okay, so there was a hand over here and a hand over there. So let's this and then you. Okay, go for it.
I think you cannot use new for the arrow function, so you can find for the property in the function, and if it doesn't have the property, prototype, sorry. If it doesn't have the prototype, then I think will be first function. Then if no, the arrow function doesn't have the prototype actually.
Correct. So we got the correct answer. Good for you. Okay, we need to clean up afterwards. So the answer is absolutely correct. So the solution for this is as following. So first of all, you know, I'm surprised that nobody actually suggested trying to use toString. And and theoretically, it could be made to work, but it would have been exceptionally ugly. Because we would have to start to parse the thing, and maybe there's a function inside the arrow and an arrow function inside the function, and it could be very challenging to properly parse it and figure out what's exactly going on. So I'm really happy that nobody suggested toString. So as was correctly stated, the solution is that arrow functions cannot be used as constructors, as constructor functions, because they don't have their own instance of this. The whole point of having constructor functions is that they get the new object as their this value, and they can initialize that object. But if you don't have your own this, then obviously that can't work. So given the fact that arrow functions cannot be used as constructors, there's no point of them having a prototype property, because the prototype, the whole purpose of that is when you're using it as a constructor function to specify the proto for the resulting objects that are created. So the easiest way to check if it's an arrow function or real function is by just checking if it has the prototype property. If it does, then it was created using the function keyword. If not, then it was created as an arrow. Okay then, so let's kind of spread the love. Pun, very bad pun. This is about the spread operator. So I don't know how many of you have actually had a chance to use generators and iterators as part of your day-to-day programming. I find them to be a really, really cool feature, but apparently it's not a super popular feature. But anyway, so let's say we have a generator function. You know, you use function with the asterisk notation to declare it, and it yields 1, then it yields 2, and then it returns 3. And now I use the spread operator to create an arrow from the values returned by this generator. So my question in this case is, without using a console, what would be the value or the content of the array assigned to A? Over there.
Okay, sorry for persisting, but that would be a 1 and a 2. It's given by how iterators are implemented. The last value will be returned as a value 3, whatever. The iterator pattern will only go through the yields and not the return value.
Correct. So here, you win your duck. Let's see if I can throw it that far. Wow. Okay, so the correct answer is indeed an array containing just the first two values, the values returned by the yield. And to understand why that actually happens, you need to understand a little bit about how a generator actually works. So when you call a generator function, like we do here on the left-hand side, it doesn't actually return the value. Like if it was like a regular function, what would be returned is the value 3. But that's not what happens here. When you invoke a generator function, what you actually get back in return is an iterator object. And the spread invokes that iterator until so whenever you call the iterator, you get back an object that has a value and a done property. And if you have a truthy done property, then the iteration stops. So you really take only the values for which done is falsy. And if we look at the iterator returned by this generator, what we will find is that this iterator actually returns these following 3 objects: false, false, and true for the done value. So the return 3 actually does do something. It does return a value through the iterator, but the done value for it is true. And since the spread operator only goes as far as long as done is falsy, or false in this case, then the last value is actually ignored and not used. By the way, if you used for of, this exact same thing would happen. In fact, the only way for you to actually get at the value returned by the return is to manually write the code that uses the iterator. So you can literally call the generator, get back the iterator object, and then when you invoke the next method on the iterator, you will see that eventually you will actually get that third value with a 3 and the done equal to true. Now, why was it designed this way? I don't know, but that's the way that it works. Okay then, coming up on our last riddle. Maybe I should have prepared another one. We're moving really quickly. You guys are awesome. So, let's say we have this really interesting assignment. Now look at the code really as is, as it appears on the screen. My question is, given this expression, what would be the output? And again, let's make it a little bit more challenging because you guys are awesome. Obviously also, why would this be the output? Okay, any sacrificial lambs?
I'll sacrifice. Looks like that's what I'm doing today. My first guess is going to be 1 array of 3 and 0 array of 2.
1 array of... I don't exactly follow what you mean. I apologize.
The first, obviously, is going to iterate over the 0, 1. It's
Okay.
going to put the value into the variable v, so the first log will be 1 and array of 3, 2, and the other one will be 0, an array of 3, 2.
And you're...
Array of array 3, array 2.
And you're incorrect. Sorry.
Thought so, but someone had to sacrifice.
So. Sorry? Oh. Sorry. Nervous twitching on my part. Oh, okay. We have another candidate here.
Okay, so for the V, we have the 1 and 0 values, and for the A, we have an array which contains 2 arrays, with the array contains the first value 3, and the second one, another array which contains an array with the first value 2.
Wrong. Go for it.
So it's
Just before you answer, I really love it. You know, all of you here, JavaScript coders and experts, don't feel bad, by the way. When I initially wrote this code, it kind of is like this code by accident, and I got the result that came out. I was like so shocked. I had to like literally try to debug it and figure out and single step through it and try to figure out what happened, and it took me a while. So definitely don't feel bad if you get back the incorrect result. It just goes to show how interesting the JavaScript language is, and yeah. So again, please don't feel bad if you get the wrong answer. Like I said, I actually got the wrong answer myself the first time I actually ran into code that kind of looked like this. So yeah, please go for it.
Okay, so the first line produces an array that contains the array 3 and the array 2, and then actually continues on the second line. So we're accessing the first item in that array, which is array 3, and then we run for each on that. So V will be 3 and A will stay undefined. So it's 3 and undefined.
Correct. I should have had you around when I was debugging this. Which colors do you have already? You have black, so you don't have purple, right? Okay, so you've got the entire collection. Okay, let's explain exactly what's actually going on here because it's interesting. So the problem here, and what really got you all confused, is the fact that you seem to think that what we are seeing here are two separate JavaScript instructions, when in fact what we're actually seeing here is a single JavaScript expression that spans 2 lines, because there is no semicolon. Now, we all like to think about JavaScript as a language that doesn't need semicolons, but that's not the correct definition of the language. JavaScript is definitely a language that does require semicolons. So what's going on? The point here is that the way the JavaScript parser works is that when JavaScript runs along and encounters a situation where there's a sort of a parsing error, it will then try to back up, insert a semicolon when it thinks a semicolon might be missing, and then try to reparse that expression again. So in this case, a semicolon would be inserted between these 2 lines only if parsing these 2 lines as a single expression would fail. But in this case, it doesn't actually fail, and as a result, it's just parsed as a single expression. So what does it actually mean as a single expression? So, as was stated, this will be the output, 3 and undefined. So, the expression is essentially equivalent to this, as if I wrote it on a single line. And again, the line didn't exactly fit inside the slide, so think about it as one long line. So we've got the map, and right after the map, we've got the square brackets with a 1 and a comma and a 0. But the comma is actually we're not declaring an array here. What we are, in fact, is using the comma as the comma operator. A comma operator basically takes 2 expressions in JavaScript, evaluates the first, and then throws away the result and evaluates a second and returns the result of the second. So in this case, 1, 0 is exactly like writing just the 0, in this case, inside the square brackets. So it's really what we get here is we've got an expression like the map returns an array containing 2 arrays, one with a 3, one an array containing just the 2. Then we've got the subscript operator on it, returning just the first one of these, so we get back an array containing just the 3, and then we do a for each on it. So we really just do a for each on an array containing the number 3. And since A was declared using a var, because of hoisting, we can actually use A inside this expression because the declaration of A was hoisted to before this expression was actually run, but A was never yet assigned a value. So A is still undefined within that expression. If we try to use let instead of var in this case, it would break because we are using A too early. So really what we ended up with is 3 and undefined. So I see I finished 7 minutes early, Bruce. I'm letting everybody early out to lunch. I will just finish by saying that I have a whole bunch of additional riddles. Each time I give this talk, I try to vary them around a bit. If you're interested in some more of these riddles, either just look me up on Twitter or do look for hash JavaScript Riddle on Twitter. You'll find a bunch of my riddles. And in any event, I'm always looking for good new riddles. So if you have ideas and suggestions, come see me. And if it's a really good one, I still have a rubber duck or two. I'll give them to you. And again, thank you very much.
Thank you, John.